welcome to the newest edition to National Gypsum's AIA-approved webinar series, Unlock Acoustic Excellence. My name is Scott Hughes, and I will be co-presenting along with Thad Goodman today. We are part of a team of construction design managers whose responsibility it is to not only help you choose the best products for your projects, but also to be a training resource to you and your firms. Our goal today, as with all our webinars, is to build knowledge together, but we do have a few quick things to review before we get started. Since we have a good turnout on the webinar, all attendees are in listen-only mode, so we'll have to use the Q&A in order to ask any questions. So please submit any questions to that Q&A at the top of your screen. Several of my counterparts are going to watch that, and they'll be able to answer your questions as they come in. AIA credits will be submitted on your behalf if you included your AIA number at the registration. If you're calling in on a phone, we don't know who you are, so please, in the Q&A, stick your full name, email address, and AIA number so that we can make sure we get a credit recorded for you. All attendees will be sent certificates as long as we have an email address for you. So with that as a quick background, we'll go ahead and jump right in. Speaking of the credits, it is a health, safety, welfare credit for today, as are all of the National Gypsum AIA Lunch and Learn programs. So a little bonus there. And we do copyright all of our programs. So we ask that folks do not record this on their own and then distribute it. If you'd like a copy of it, I'm going to have you reach out to your local construction design manager, part of my team, who I'm going to introduce to you here just in a second. So that's how we're happy to provide a PDF version of the presentation. So here's the team. Thad Goodman is my co-presenter today. He is in the center north part of the country there. He covers the states that are labeled MWA as well as CEA. I'm to the right, and I cover all of the Mid-Atlantic as well as New England states. On the left is Pat Grotlish. She covers the western area. And then kind of going south here, Amy Wilson in Texas covers the southwest states that you see there. And last but not least, for the true marketing team, or the construction design manager team, is Alan Zedek. Alan lives in the Florida market, but covers all those southeastern states. Bottom left is Jordy Polk. Jordy is a huge help to all of us in various ways, but she is responsible for sustainability documents, our EPDs, and things like that we'll talk about at the end. So she's in charge of those things. And then bottom right is Amy Hockett. She is the manager for all of the architectural reps, as well as our sustainability efforts. So bottom right there, you see nationalgypsum.com/expert connection. That's how you can get all the contact information for these folks. But we are going to follow up with an email to all participants in the next day or two with links to all of your contacts and some of the information we're going to discuss today. So we promise we'll get you an email out in the next several days. Before we jump into the program itself, just wanted to give you a quick background on who National Gypsum is. Obviously, we cover the United States with all of our plants. We have three basic product manufacturers. Gold Bond Building Products is our drywall. So that covers all of our standard drywall, mold resistant, fiberglass mat drywall products. The gold on the map indicates a plant or a quarry. The red indicates our ProForm finishing products. That is our joint compound, whether it's a ready mix setting, joint compounds, and everything needed to actually finish the wall. And then you see there are four blue dots. Those are our cement board plants, which is our perma-base cement board. So we got the country covered. We can rail or ship or truck any of the material we need to all across the country. So with that as all a background, we're going to jump into what we'll talk about today. Today is really a program on STC. So the bottom line is that's really what we're going to focus on, how to achieve various STCs. We're going to show you various ways to do it, but we need to do kind of an acoustics 200 level class first. And the reason for that is we want to make sure everybody's on the same page when talking to customers, when talking to clients, about sound. Sound is not a black and white thing, right? We all hear differently. Some people hear better than others, just depends on life experiences and things like that. So it is a difficult thing to actually talk to somebody about and educate. So we're going to give you some background. That's really be the focus today. Talk about using your partitions in reducing sound from one room to another. That'll be the focus. Lots of different ways to do it. We'll cover it all today. I will review some code requirements and industry associations suggestions. So we'll spend a little bit of time on that, but I'd rather spend most of our time, and Thad and I would, on the nuts and bolts of the actual partitions and wall assemblies and how to achieve various STC ratings. And we'll do that through different strategies and competitive systems to get to the proper results. So the outline real quick, I'm going to start with acoustics 200 level, maybe a little bit into 300 level. So we will dig a little bit into the weeds on acoustics and get some terms out. And then we're going to talk about design considerations, meaning there's several ways to get certain STC ratings. And no matter which way we pick, whatever nuts and bolts and products we use, there are some common things we need to consider. So we'll make sure you get a good understanding of that. And then we'll get into the solutions. Thad's going to go through some specific designs. So we're going to show you a lot of specific wall partitions and get into how they perform and how things like studs and whatnot affect the actual results. So let's start with the acoustical concepts and terms. As a gypsum manufacturer, I think probably the most often question we get as construction design managers, architectural reps, and our technical support line is usually fire related, right? It's a fire rated wall. It's a specific condition on a job that is really difficult to figure out how to do it properly according to UL. So that would be number one. But number two, and a very close number two, is sound. So it's everything about acoustics. Obviously, no matter what you do for a living, whether you design homes or you design schools or you do retail, big corporate offices, sound matters. If you think about your day-to-day, the quieter the environment, the easier it is for you to get your work done. And think about kids, same thing. If there's a lot of ruckus going on outside or in the hallway of a school, kids can't concentrate. So we need to keep, we need to use our partitions for ceiling assemblies to keep the sound at a comfortable level so that we can learn. So that's really the focus today. We're going to walk you through all of that. USGBC, as well as AIA and ICC and some others have some recommendations. So we won't spend a lot of time on that, but I will show you what those are. And we're really going to focus, though, on the 6 design strategies to help you get the results that you hope for when we're planning our buildings. So we'll start with airborne sound. I'm going to spend a few minutes on each one of these bullet points. Some of it's basic. I'm sure, like, you look at decibels, well, I know what that is, but it's important that we kind of go through each one of these and show, no matter what parts and pieces we decide we're going to go with, what products and manufacturers want to use, there are some common things that we need to do. So that'll be the focus here for the next several minutes. First will be airborne sound. So right now, airborne sound is me. I'm actually generating the noise, right? The noise hits the microphone on my computer, it goes through the internet, comes out your speakers, and it hits your eardrum. There's vibrational pressure waves happening through all of that. If you've ever seen a subwoofer or a bass speaker in a stereo, when the volume's turned up and how it vibrates, and you can see it vibrate, that's causing vibrational energy. And that's what makes noise, penetrate through a partition, like you see the big red arrow there. So airborne sound is what STCs measure. That's the focus. So when we're talking about an STC rating, we're talking about airborne noise. In our case, for what we do for a living, it's human beings, mostly. Now, there's TVs, there's certainly airplanes flying by, big city traffic, train tracks, those kinds of things. But for the most part, the STC is going to measure human sounds and all ages, from very young to very old. So that's key. But what we do need to concern ourselves with is the blue arrow and the green arrow and the orange dotted line arrow. So they're the things that no matter how much time we spend on that partition, if we don't consider how sound can generate or vibrate through other parts of the building, then we're probably wasting our time, right? So we need to discuss all of those different things. And the first one here is flanking sound. Think of a hardwood floor. Everybody likes wood floors and tile floors. Worst performing thing for sound, right? Carpet would be the best, but everybody wants the hardwood. So high-heeled shoe, dress shoe, hard-soled shoe, walking on the floor, going click, 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 click. vibrating right underneath our partition that we've spent all our time and effort to design a high STC, right to the other side. They can hear that, right? So there's ways that we have to attack that, no matter, again, what type of system we choose for our partition. So caulking is certainly one. I'm going to get into caulking a little bit later, but there's certainly ways that we can attack this. And you'll see those purple, not purple, I guess they're purple, purplish blue arrows kind of coming out the middle of the wall there. You know, sound can travel up through the cavity of the studs and out an electrical box too. So we'll show you how we take care of those here in just a few minutes. Now, when we talk about STC ratings, so there's a test that we have to do to come up with an STC. So my next couple slides, we're going to kind of get you familiar with what that is. But to start with, we have to talk about hertz. STCs are measured in hertz. So backing up one step, when we are born, provided everything is normal, we hear very well. Babies hear everything. They hear from a range of 20 hertz, which is a very low sound. In fact, most of the adults, myself included, can't hear that. It's too low of a sound. Think of machinery with a low hum sound to it. And then it goes all the way up to the kids can hear all the way up to a 20,000 hertz, which is this high pitched, almost like dog whistle type sound, right? So as an adult, we can't really hear that. Most humans are sensitive to the range of 100 hertz to, I'm actually going to say, about 10,000 to 14,000 hertz. It really depends on your age. I'm going to have a little video here we're going to run in just a second. We'll give you a good understanding what that means. But we are sensitive to that range as adults. Now, kids hear better than us as an adult. So the teenagers, the single digit kids actually do hear very well, despite them saying, "What did you say? Huh?" They actually do hear us. Typical speech is between 125 and 4,000 hertz in a commercial building or in a residential home. That's the range that STCs test. But I'm going to show you that test after a quick video. Play along with this video here at your desks if you can.
We've gathered a group of volunteers ranging in ages from 8 to 71 and are putting them to the test in our first Battle of the Ages contest.
All right, you guys, I'm going to play a series of sounds, and if you can hear the sound, I want you all to raise your hands up. Your right hand, you're going to keep it there, all right?
For those of you watching at home, feel free to play along.
Ready? 8,000 hertz. All right. All of you can hear that first frequency. Now I'm going to play another sound at another frequency. If you still hear it, keep your hands up. If you can't, bring your hand down. 10,000 hertz. Okay, we seem to have lost our 60 and over crowd. You guys look great, though. Let's raise the frequency even more. 14,000 hertz. Okay, we lost you, we lost you. You're very fit, I can tell. 16,000 hertz. Okay, at 16,000 hertz, we've lost all of our grown-ups. But we still have our youngest members of the crowd with their hands up. Luke, tell everybody how old you are.
8.
8 years old. Your fresh ears still can pick up these faint frequencies.
I've been cleaning them.
Nice work. Now we're taking it up to 18,000 hertz. You guys ready? 18,000 hertz, we've lost 23 and 19, but the under 18 crowd is intact. 18,000 hertz, that's pretty impressive. Enjoy it while it lasts.
So
fun little video just to get you familiar with what hertz are all about. Obviously, some of those were pretty high up there. Now, we do need to talk about decibels before I talk about the STC testing. So one quick thing on decibels, right? That's volume. It's how loud something is. And again, we all hear differently. So 50 decibels to you might be different than 50 decibels to me, but we have to have some kind of a basis. So as we look at the chart, if you look the first third there, you get to normal conversations. It's somewhere around 60 decibels. So if two of us are in a room, we're sitting across from a table talking to each other, it'll probably be about 60 decibels. When we do presentations in crowds or in conference rooms, the speaker tends to have to elevate to about 65 decibels because all of the bodies in the room absorb the sound. So those bodies up front absorb a lot of sound, so the folks in the back can't hear. Speakers have to elevate their voice a little bit. 0 decibels is what we call a hearing threshold. Okay, as an adult, we hear nothing actually, as a human being, we hear nothing at 0 decibels. There's always sound. There's no such thing as no sound, but we have to have a starting point. So 0 is no sound. Think of 60 as a normal conversation, like I'm talking right now and you're hearing through your speakers. And then as we get louder and louder and louder, say 100 decibels or more, if you're exposed to that for too long of a period of time, it will actually cause physical pain in your eardrums or in your ears. So think about the last time you went to an indoor concert, like maybe a rock concert or a horn concert, something that's indoor, lots of instruments, lots of noise, and how you felt, what your ears did when you left, right? You got home, well, you actually don't even have to get home. You leave the venue and your ears start to ring a little bit. You can kind of feel that and hear that. And then when it's quiet at home, when you're ready to go to bed, you put your ear on the pillow and you kind of hear this little ringing sound, right? That's not good, by the way. I mean, the music was too loud, but exposed to that kind of thing can actually cause pain. So obviously in the buildings we design, usually we don't have amplified rock, jet planes flying through the rooms themselves, but we certainly want to be concerned with how we increase or decrease the decibels as they come through our wall partition. So this is just a cool little chart. 1 to 2 decibels change. So from 60 decibels to 62, or from 60 to 58. As an adult, we don't hear that. It just doesn't affect us in any way. It just sounds the same. But once you get to 3 decibels, then it starts, your brain clicks that, yeah, okay, the volume's either a little bit louder or a little bit quieter. And then at 5 decibels, it's very noticeable. And I won't be dramatic. I could start whispering or something, right? But at 5 decibel change, it's very noticeable, which means we're starting to do something. It's either getting louder or quieter. Our discussion today, we really want things to get quieter, right? So I'll keep it on that focus. Now, look what happens at 10 decibels. At 10 decibels, if we go from 60 decibels to 50 decibels, we basically cut the sound in half. That's huge. And then at 20 decibels, it's 4 times quieter. Now, that's hard. So realistically, our goal needs to be somewhere between that 3 and 10 decibel range, right? Now, there will be rooms where we need 20. I mean, there certainly will be projects, but for the most part, 80-20 rule, we're going to go, we need to drop 3 to 10 decibels. So to relate that to STCs now, it's not a one-for-one even swap, but it's close. Meaning, if I have an STC rating of 50 and I design another wall with an STC rating of 55, now higher the STC, the better it is at reducing sound. It's a good thing, right? But the higher the decibel, the worse it is. That's not good English. The bad it is, the worse it is. So if I go up 5 points of STC, so you think that, well, I'm dropping 5 decibels, making it 5 decibels quieter. Kind of, okay? So it's not a black and white answer. It's very close. So just keep that in the back of your mind. 50 decibels, geez, Scott, 50 STC to 60 STC would be about, 10 decibels quieter, right? Because remember, STC up is good, quieter, where a decibel up is louder. So all of that being said, now we get to an STC and how we actually tested what it is. So an STC is a sound transmission class, is what it stands for. It is a single number rating system so that we can compare one wall assembly to another when it comes to its performance of these various frequencies, right? We talked about the hertz, the various frequencies that are thrown through your partition. Because a young kid's voice versus an adult's voice is a different frequency, right? It's a different sound. There's different sounds in buildings at different frequencies. So what the STC, when we do an STC test, we actually build a room, have a test wall, and another room on the other side. And in that room that we built, which I'll show you here in a second, there is a speaker. And that speaker is going to throw out noise. It's a pink noise. And in that noise, they're going to have 16 different frequencies all at once. They're going to start at 125 hertz. That's pretty low, okay? And they're going to end at 4,000 hertz. Now, how they do that is at 125 hertz, they make a sound. And then we do what's called third octave testing. That's those 16 different frequencies starting at 125 and ending at 4,000. Any musicians out there, anybody that's played the piano or can read music, just for argument's sake, picture middle C on the keyboard. You touch middle C and you go up 3 notes. So C, you go make a noise at C, then you go D, E, F, right? Make a noise at F, then you go G, A, B, make a noise at B. So every 3 notes, we do that 16 times. And when you start at 125 hertz, you end at 4,000. Now, the interesting thing to note is the higher the STC, the better it performs at reducing sound. Good thing. Higher number, good thing. But going from an STC 30 to 35 or even 30 to 40 is not a big deal. That's going to show you this here in just a minute. At 30, you and I can have a conversation. Almost like there's not even a wall between us. At 40, I may have to elevate to, I don't know, 65, maybe 70 decibels, but you're going to hear the conversation. It's still a very low performing wall. Now, if you're at 50, it's a very good wall. I have to really elevate my voice, and you maybe will pick out a few of those words. More of a murmur is what you'll hear. But if you go to 55, just that 5 points, you're not going to hear a thing. So the higher the number, each point of STC performs even better. Now, let me throw one more wrench into the discussion. So the last wrench here is at the chart on the right, you see that's a sound test. If you look at the red line, we're making a sound test over, let's say, 5 to 10 minutes. We're going to make this pink sound noise, and it's going to come out all these different frequencies, and we're registering in the other room using a microphone what's coming through. You can see at the lower frequency of 100 hertz, it's a 40 STC. But as you get to the higher hertz, 2,500, 3,000, it's all the way up to 60. So, but if you look above the chart right there, it says STC class is 57. 57 is the result. That particular assembly that was tested performs better at the higher end. So that's what's key. We need to know what sounds we're trying to eliminate. Eliminate's the wrong word, reduce. And then we can decide which partition is going to perform better at those hertz. Okay, so I promise you we're not going to get much more in the weeds than that. But the bottom line is sound is not black and white. So we do test according to ASTM standards. E90 is basically build 2 rooms. In between our rooms, we have our test wall. The one room has the speaker and a microphone, so we know how loud it is. And then the other room has a microphone, and that microphone is attached to a computer, and it's pulling in how much noise at those 16 different frequencies is coming in to a computer program, and ASTM E413 spits out what the STC will be. So that's it. I mean, that's in essence, there's a little bit more to it than that, but that's the basics of how we test for sound. The interesting thing is we can actually do a test for 10 minutes, 5 minutes, 10 minutes, shut everything down, wait a half hour, start it all up again, didn't change a thing, and we might get a different result. So that's why I say sound is not black and white. There is a gray area to it. Now, the results will be very, very close, but they're not always exact. So let me do real quick. We talked about code. I want to hit code, and then we want to get into the nuts and bolts of the various wall assemblies out there. So ICC recommendations all the way back to 2010 basically say that the laboratory acoustical performance in one of what they would call acceptable performance, right there in the middle of our screen, grade B would be an STC 55. So that's good. That's great. It's not super, but it's a very good STC. But what they're saying is, even though that's what's tested, so we pick the products and all the assemblies that made that test work, we stick it on the job site, the contractors install it, and then we go and field test it. Code allows for a 3-point drop. So that could actually test out in an STC 52. Going to the far right, grade A, preferred performance, an STC 60 tested, right? Those ASTM tests I just talked about. If we install it, contractor puts it all together, perfect, just like they're supposed to, it's allowed to come in at 57, a 3-point drop. Meaning that if you actually need the performance of an STC 55, you're going to need to specify an STC 58 wall to allow for that droppage, because in the laboratory, everything's perfect. Everything's assembled with folks with lab coats. On a job site, not so much, right? So code does allow for that. Keep that in the back of your mind when it's very, very crucial that you hit a specific STC. Facility Guideline Institute has put together recommendations through and for AIA for healthcare. The point of this slide is basically, hey, sound is a big deal. I mean, we all know that, but in the last 4 to 5 years, we have really seen it explode. In how do I get higher STCs and higher STCs, and the codes are starting to require higher numbers. So as you can see here, we've got some big numbers for certain rooms. LEED version 4, 4.1. I understand LEED version 5 will be out next year. Has recommendations or requirements in order to hit this particular credit, part of the credit anyway, part of the acoustical credit. So again, the point of the slides is code driven in some cases, well, actually a lot of cases, and it's also a preference for some of our higher end type buildings, high end residential, high end townhomes. If you're spending $1 million on a townhome, like in the Washington, D.C. market, you do not want to hear your neighbor, right? So we will have unhappy clients if we don't pay so much attention. So with that, I'm going to turn it over to Thad so that he can talk about some design considerations.
Thank you, Scott. We've had a number of people that came on a little bit later, so I will just reiterate the fact that we've got about 20% of our crowd right now who has joined just by a phone number. If you would be kind enough to put your name in the chat so we can match it to your registration, we can make sure you get your certificate. We don't want to cheat anybody out of their time that you spend here. We truly appreciate you being here today. And with that, we'll go into some design considerations. There are 3 main things that control sound transmission. 3 ways to improve a rating on the wall. Now there's 6 different strategies that we're going to discuss today to do that, but there's 3 basic ways that we're starting that conversation. There's mass, pretty easy to understand. The more things you put in the way of that vibration, that energy that Scott talked about earlier, the harder it will be for that signal to transfer its way all the way through the wall. And we'll talk in just a second about how we deal with some of that mass. And then you have space. How much space do we have between the 2 planes of the 2 membranes that we have on each side of that wall? The more that we have, and there's several different ways to be able to control that. And then damping, which is kind of a newer technology for the construction industry. It's been around since the 40s in the military, but it's basically that the thought process is that you take an empty wine glass maybe and you ping it and you listen to it ring and then you put your hand on it. And so it's a way to take the energy that you have and move it forward. Head back just for a second, Scott. Thank you. Stiff on the trigger. Stiffness of the wall makes a big difference from an STC perspective. Metal framing is more resilient and works better with wood studs. So metal framing outperforms wood studs. That's good for us in the construction industry, and especially in the commercial part. The spacing of the studs, the number of contact points, makes an amount of difference in each panel. So if you think maybe about what we do with continuous insulation and thermal bridging from the outside of a building to the inside of a building, sound is kind of the same way. When we're trying to keep sound out of one room and locked into one, the less contact points we have in that framing with those screws going into the drywall, into that framing member to transfer through, make a big difference. Cavity absorption, insulation in the cavity makes a difference. Full is better. You want to eliminate as many gaps as you can, but you don't want to make it too stiff. And so we get into this discussion sometimes with builders who say, well, I'm using a blown-in insulation. That should be better because I'm covering every single inch of that cavity. Well, the problem there is you're stiffening up the wall, making it even stiffer than it is. So you've probably negated what you added with the cavity absorption from a sound perspective. Now, we have many reasons we use insulation. Thermal protection is one. Cavity depth, that's pretty simple. Like I said earlier, one of the ways that we do that is we just add a wider stud. Sometimes we decouple it using a couple different avenues. And so now we'll go into some of the places that we do that, and we'll show you some examples. So the first thing we talked about is mass. Mass is pretty simple. From a gypsum perspective, adding more layers makes a big difference. If you sit in a movie theater, you may not hear anything except a low thump from the theater behind you or beside you. And that's designed that way because there are 6 or 8 layers of drywall on each side of that wall if it's a metal or a wood stud wall. So in this example, we have an opportunity to see the exact same stud assembly, 3 5/8 metal studs, 20 gauge, 16 on center. We leave an open cavity on one side just to show how poor that STC would be if you had that single membrane, even with some insulation in there. And then if we just add one layer of gypsum to that particular side, if we stay on the same side of that wall, so we've added more mass to one side of that wall, we've gained 4 STC points. Stiffness is another way that we talk about one of the things that we mentioned earlier. So here we have 2 similar assemblies, 3 5/8 metal studs. One is 20 gauge, one is 25 gauge. So there's a difference there. The spacing is exactly the same. We've got the same materials inside the cavity. We've got the same amount of drywall placed in the exact same assembly on the outside of that stud assembly. And because we went from a 25 gauge 24-inch on center to a 20 gauge, so now we have a stiffer stud that's going to allow sound to go through, we've lost 4 STC points. So again, the stiffness of the wall makes a difference. And when sometimes there's times where we design a wall and we start down the road saying, okay, we're going to have 25 gauge metal studs, 24 inches on center, but we'll have a part of the building where we have limiting heights, maybe with the metal. So we have to go to a 20 gauge, just to understand what the effect that it has on your design. Cavity absorption. We get the question all the time. I've got a test, I've got a sound test, doesn't have any insulation in it. If I put insulation in it, what am I going to get? Well, here's a very resilient system with 25 gauge metal studs that shows an actual 8-point bump by adding nothing but insulation. I will tell you that this is not normal. When you get into stiffer stud cavities and in that 20, 25, or that 20 gauge, 16 gauge area, you're going to find 2 to 3 STC points, maybe 5, depending on whether it's rock wool or not. So there's some different ways that we can manipulate this. It's not consistent. It's not like you can say any cavity that I have, I can throw insulation in, I'm going to get 8 points. So that's why the tests are so important. And while I'm here, let me just make a quick comment about the outline of these slides. When we put these slides together, we basically showed you the picture because we're all visual. So we want you to see the picture of what's there. And then down below, we're going to describe what's in that picture. So if you look at the framing, the insulation, one side or the other side, so we can give you the opportunity to see what it is. We'll put the STC on the left-hand side. And on the right-hand side, what you're looking at is a test number from a sound tested lab. So if we get to the point where when you start to look at these through some of the resource books that we'll introduce later in this program, if you want to have a copy of that test, we'll happily provide that, but we don't make them publicly available anywhere, just for the general audience. And then we'll go ahead, Scott. Thanks for giving me the minute to explain that. Okay, cavity depth. Another question we get on a regular basis is, I've specified an STC, I need to put a call box, or I need to put some sort of a fire box somewhere in the cavity. I'm going to have to put it deeper I'm going to have to go deeper in the cavity. We do this a lot in the medical world. This shows wood studs, but it happens a lot in the medical world where you're hanging a lot of things on the wall. So I need to gain a couple extra STC points. If I move to a deeper wall cavity, can I get those? How much can I get? And in this example, a wood stud is very stiff. And so in one of the most stiff systems we have, when we go from a 30 or from a 3 5/8 to a 6-inch stud, we've gained 2 STC points. So cavity depth makes a difference. As we start talking about number 2 in what I said, controls sound, and that's space. So cavity depth does make a difference. If we want to go crazy and we have lots of real estate and your owner has all the money in the world, we can do a totally decoupled double stud wall. This is probably the best wall you can get from a sound perspective because you've decoupled all the contact points inside that assembly. You have 2 headers, 2 footers, all the way through. You've got insulation on both sides. You've got double insulation. takes up a lot of floor space. So there's times where people say, I can't give you 9 inches, but I might be able to go with a common header, maybe a 6-inch header, and then I'll just stagger the studs inside. There's a couple different options here. One is to put insulation, squeeze insulation in between that middle stud, put it on one side, put 2 layers of insulation in there, or to weave it through like a snake. Both of those will have different effects on your STC, and you should look at the test to make sure you've done that correctly. Again, as we look at other space, one of the other ways we create space is, and as we decouple the wall, we look at, here's a good example from what we can see from a standard 3 5/8 metal stud wall. And then we've gone to what we said earlier was probably one of the better walls that you can get, one of the most effective, because you decoupled that wall. And we went from a 46 with basically most of the same stuff to a 60 STC. And as Scott said, anytime you can go 10 extra points, you're going to hear half of what you heard. If you go 20, you're going to hear 4 times less. And so here we are even past that. So huge difference here between these two walls. Another way that we use a combination of mass and space, or mass and space, is we will decouple the wall with an RC channel. These have been around for over 60 years. They're very effective with what they do. You typically see 2 layers of drywall on the other side of that picture on the right, where that open stud is. And then on the right-hand side, you'll see it decoupled with an RC1. And so you've created some more space and you've created less contact points. When you get to this type of an assembly, whether it's 16 on center or 24 on center, isn't quite as important because you've decoupled it on the one side. Does a great job of doing what it needs to do, as long as you can keep the owner from understanding what it is and make sure that they don't short circuit the system when they get in there. We had a hotelier that was actually nailing headboards to each side of the wall and using this system, and couldn't understand why they didn't have good sound effects, good sound transmission. And that the reason was because they had destroyed their system. So as long as the owner understands the rules, this is a great system to use, and we'll see an example of it here. So here we go back to that same 46 wall we looked at earlier against the 60 with the totally decoupled wall with the double stud wall. Now we've done something a little simpler. We're using much less space. We just decoupled one side of that drywall with the RC1 channel. And now, because we've decoupled it, we've gotten ourselves 6 extra STC points. So we've gone from below the code requirement for multifamily to above the code requirement for multifamily. That 50, as Scott said, is kind of the benchmark that we shoot for as the minimum with good sound wall control. If we want to move it up to the next level, if we want to control a wider frequency of sound, we can introduce sound clips. Sound clips get an extra layer of protection against vibration. They've got the pneumatic or the rubber pad they put right against the stud. You can see a picture of it there in the middle left. And then it goes right against the stud and it gets screwed into the wall. Then you use a channel that attracts it. So that gives you an excellent STC perspective. And we'll look at an example of that. Here we start with the 51 that we had previously with the decoupled wall. So we went from a 46 and we decoupled it to a 51 by adding the resilient channel. And then in this particular case, again, you've got the exact same wall assembly, and now you're using the RSIC clips or the pack clips, whatever you want to call them. There's a couple, 3 different names for them. Isolation clips is the general term for them. And so when we add an isolation clip, we go from a 51 to a 57. So if you think about that previous slide that we had where we started in just a 3 5/8 metal stud 20 gauge wall that was a 46, now we've moved to a 57. So we've jumped 12 points by adding this particular technology. So we've decoupled to another level. Here's 2 different levels of decoupleization that we're showing right here. Another option is to use an acoustically enhanced gypsum panel. This used the dampening system that we talked about earlier. This again uses 2 different methods of what we talked about to control STC. There's two thin layers that are highly compressed gypsum. So you've got more mass in this gypsum panel than you would in a typical 5/8 type X product. It's still 5/8 type X, but instead of 2.2 pounds, it'll be 2.8 or 2.9 pounds because we've taken as much air out of the system as we can, made them totally solid gypsum with both of these small pieces of drywall put together. And then in the middle, where that number 3 is, you can see the middle of these have what's called a viscoelastic polymer, which is kind of like tree sap. It never gets completely hard. And what happens is as sound starts to vibrate through that panel, it meets that dissimilar product in the middle and it confuses the sound. It actually changes it from an acoustic wave to a thermal wave, although you don't get any thermal protection on it. It doesn't create a lot of heat, but that's actually chemically what's happening. Very effective. Here's a good example. We start with a 3 5/8 metal stud wall that's 20 gauge, 24 on center. That's a 44 STC. If we just take one layer of that drywall off, that 5/8 type X regular gypsum off, and we add one layer of a damped panel in that same assembly, we jump from a 44 to a 55. So in a relatively stiff system, we've gained 11 points. Now, again, you're not always going to gain 11 points every time you do this. That's why it's important to have the tests and go through these. But damping is a very effective technology. We call it thin wall technology because if you're on a project and you have a situation where you need to change an STC in progress, your MEP is set, your door frames are set, and you've got some sort of a change on the job, the owner wants to make a change, maybe move an HR building, an HR room somewhere, or an executive office, you can pop out the regular drywall, you can put this in. It's a plug and play model that can keep you going without a lot of different deconstruction or moving around of your mechanicals, your door throats. Okay, there's some best practices that Scott's going to go through now. I'm going to hand it back over to him and he can kind of give us some Sound 101 pieces.
I get that. So we saw this slide earlier. This is the flanking sound slide. And the focus here now is back on those things that we need to do no matter which of these assemblies we've chosen to meet a certain STC requirement. So now we need to talk about caulking, that vibrational energy that's going to go through on the floor or an adjacent wall. Think of a door opening and closing in an office. That wall vibrates right through to the next office, right? So what we want to do for these higher STC wall partitions is leave a 1/4 inch gap around the entire perimeter of that wall and fill it with acoustical sealant. My company does not sell acoustical sealant. That's not why it's in the program. It's super important for long-term performance of our STC. If we're going to invest in an STC 55 or 60, we want to get that performance, right? So the caulking is important. Let's assume for just a second that the contractor did it properly. They installed this 3 pieces of vertically installed drywall, 4x10, 4x12, whatever it is, left a 1/4 inch gap, but the finisher, the folks with the joint tape and compound, come and cover it up before the caulk gets there. That defeats the whole purpose of having this a caulk there. You've got to have the caulk. You're going to lose all kinds of points just because of that little tiny gap that the vibrational energy and the airborne energy, airborne sound can get through. Super important that we do the caulking. It is a discussion that needs to happen with our contractors prior to them installing these walls. Stuff the flutes, okay? Lots of different products in the marketplace to do this. If air can get through, obviously sound can get through. So basic, just showing insulation here, but there are all different options and ways to do it. Fire caulking. The key with the caulk is it's a flexible caulk, okay? It doesn't have to necessarily be acoustical caulk, but it has to be a flexible caulk, both fire rated, non-fire rated. If you don't need the fire rating, lots of different options out there in the marketplace for you. Now, here's an example, obviously looking sideways at a wall. So if the daycare is on the left side and the next tenant, it's a strip wall, there's a tenant on the other side, and there's maybe a doctor's office or an exam room on the right-hand side, right? That doctors, they don't want to be interrupted by a bunch of kids having a lot of fun and screaming and happy on the left-hand side, right? So we need to caulk both sides. the great thing about STC testing is it works both ways. You see the purple board there on the right, it doesn't matter what side of the wall it's on. It will work both directions, both identically, okay? So that's why we want to caulk on both sides. Super important we caulk to reduce that vibrational energy of people running back and forth on that floor. And then you don't see it, but the wall, the partition wall, and another wall at a T-joint, you know, you're going to have vibrational energy hitting that too. So we want to caulk around the entire perimeter. Putty wrap the electrical boxes. This is a big source of air leakage through a wall partition, right? Because as you've got a box there, you can't have insulation. Insulation absorbs all kinds of energy and all kinds of sound. It's great for that. Dad's already talked about that. So the less disruption we have in our stud cavities, like you see in the green check versus the red X, the more insulation, the better performance we'll get. Now, electrical code has to outweigh any of this, but if we putty wrap the back of those boxes, it prevents sound from leaking through the box and vibrating through to the drywall on the other side. It helps us get the actual field performance of what we've put together in the products we've chosen and the assemblies we've chosen. Again, I don't sell any of it. My company doesn't sell any of it. We don't, but there are plenty of options out there. You all get to do your due diligence, pick which one you want to specify and have at it. So there's lots of different options out there, and you can kind of see how that's installed there on the bottom right. They will actually peel off a little cover and then they'll mold just like silly putty, just almost like silly putty around the boxes. Offsetting the board joints is important for UL. It's important for sound. It's just, if I've got a board joint on both sides of that stud, that's a weak area for the sound to actually travel through a little bit more easily. So multiple layered walls, right? A 2-hour fire rated wall, you'd actually see another layer of drywall on each one of these sides. So we'd have 2 on both sides. We'd be offsetting those board joints as well. We always offset the vertical board joints for performance for fire, and it helps with sound as well. Just a little tiny thing that can make a difference, and then actually getting the field performance for that. So with that, I'm going to turn it back to Dad.
Thank you, Scott. Appreciate that. We're going to go through some of the design solutions that we see commonly asked for in the requirements for STC. And we're going to kind of lay them out. Metal studs and wood studs. We're going to divide metal. We're going to do metal first, then we're going to kind of move to wood shortly. We don't see quite as many of them in our space, but they're still important, especially with the hospitality that's been going on. So we see 45 with healthcare adjacencies and some basic sound control overall. 50 STC, minimum for multi-code requirements, and some of the LEED and FGI guidelines are 50 minimum codes. So especially in multifamily, again, hospital demising walls at 55. Most of the hoteliers want to start 50. They understand, as Scott showed earlier with the ICC document that came out in 2010, they have slowly increased to 60, 55 and 60. And then when we get to 60, we have those luxury condos. We have the school assembly rooms, healthcare MRI rooms. So this is kind of how we kind of divide things out. And we're going to show you some examples of each of those. Well, one of the things that we've done in our industry overall is the gypsum manufacturers have introduced a lightweight drywall. It's been out 6 or 7 years now. And with that, we've met the fire code requirements that we need to. We've met all the different assembly needs that we need from a fire rated perspective. One of the questions that is continuing to come up is, how do we perform per sound? And I will tell you that, quite frankly, the jury is still out. You have less mass in the drywall. As I talked about earlier, mass is one of those things that drives STC protection. So when you think about it, if there's less mass, the wall should perform less well from a sound perspective, even if it meets the same fire rating. Here's an example that we can give you to say, okay, if you think there's no difference, here's 2 identical assemblies. And I will tell you that there is a couple STC point difference. We've tested some, the more resilient ones, there doesn't seem to be much. So the jury's still out. Just know that you should always have a sound test, if you can find one, for your wall assemblies if you want to be compliant, especially on those projects like government projects where they have a minimum, and they're going to come back and test you. So again, just a little tidbit there. Basic 45 STC stud assemblies at 16 on center. We think about 16 on center with a stiffer stud. Here we are at 20 gauge studs, and we're trying to get to that 45. So to get above that 45, we typically have to do something else with the system. If we're at 50, we can get there, but if we're at 45, we need to have some help. So on one example here, we have the damped panel. The 20 gauge takes us to a 48. And while I'm on this one, let me tell you, there's a question in the chat about if that damped panel was on both sides of the wall, how would it perform? Well, the technology, any technology from a sound perspective follows what they call a mass law, which means if you want to get the same effect 2 times, you need to double the entire assembly. So in this particular case, if we put a damped panel on the other side of that assembly, it would likely test out at a 50 or a 51 perhaps. And with the cost of that particular product, probably not worth the money that you're going to spend on it. So we can go into more of that. We have another presentation that talks about that, but just to answer that question in the chat, great point, great question. It is a Type X. This is a Type X system, still meets the 1 hour as we've seen. And then we look at decoupling as we talked about earlier. So we've done that. So if we move to the stud spacing of 24 inches on center, we can get you into that 50 range that you're looking for, if that's your goal. You want to move way above from the 45 to the 50. The easiest way to do that is to go with a 24-inch on center stud spacing and your damped panel. Again, there's that 84 that we talked about earlier. The question was in the chat. If that was on both sides of the wall, that might be a 57. Again, look at the stud depth, the partition depth. You're taking up some extra space when you use the decoupling with the RC channel, but that puts you at a good STC rating as well. 16 on center. As we talk about some partition depth, we've got 50 STC with a decoupled wall here and a 6-inch stud. We've got 3 5/8 metal studs on the other side. These are both very, very stiff systems, but yet we can still get you to that 50 if we use the decoupling that we talked about earlier. So that's probably the best way. If we're looking at a very stiff stud like that, that's where we need to be. 24 on center, stud spacing, and the 55 that we're looking at traditionally, we see 2 primary ways if people don't want to use the decoupling method. And again, I said the RC1 method has been around for a long time. There are some reasons, millwork, owner requirements, things they want to hang on the wall. Probably these are the 2 most common options that we see if people want to get into the mid 50s. They go with 24-inch on center stud spacing. They go with either the damped panel that puts them at 55, or they go with the double stud. Yeah, they go with more mass. They put 2 layers on both sides, not a double stud, but double layers of gypsum on both sides. We typically think of that as a 2-hour wall, but we see it often built on job sites to get to that mid 50 range. So this is a 56, great wall from a sound perspective. Wood studs. You get to wood studs, almost all the rules change. It gets much, much harder. And we talked about it earlier. Metal studs tend to be more resilient. They give us a little more flexibility. If you look on the right, you've got a 3 5/8 metal stud wall that's 25 gauge, 16 on center, that's a 40. Same exact type of spacing on the studs. You've got 16 on center, and you've got your 2x4 wood studs, which are very stiff. You've lost 5 STC points moving from metal to wood in like assemblies at least. So one of the most common questions that we get asked is, I want to get to 16 on, I have 16 on center stud spacing. I need that for my structural capabilities on my job. I'm going to go with a 2x4 wood wall. I want to get to a 50. Okay, well, here's most of your options. You're going to have to decouple that wall somehow to get you to the point where you can get to that 50. So here's a typical wall that's decoupled. It's a 51. On the other side, we use a damped panel, and the decoupling, we can actually get to a 54. So sometimes people say, I just want to get to that 50. How do I get there or above? Sometimes they say, how close can I get to the 55 that my luxury hotelier is asking for? It's still a wood stud application. It's still got some load bearing. I need to be 16 on center. These are the two most viable options that we see out there as we start to make conversation. We get questions about mass. Can you get there with mass? And the answer is no. Mass just won't get you there in this particular assembly being this stiff. You need to decouple somehow. 50 STC in wood stud walls, 24 on center. Now that's a different story. We moved from 16 on center to 24 on center. So see the difference in just that minor stud spacing. Well, I won't say minor. Well, not everybody can do it, but if you can make that happen, we can get you where you need to be without decoupling with a damped panel. So we can get you to that 50 that you need. So you can put things on the wall. You don't have to worry about destroying the system, making changes there. The traditional way we see that is the 50 on the left-hand side where we decouple. So again, 24 as opposed to 16, that stud spacing makes a big difference. That's one of the design strategies that we talked about earlier. Okay, and we'll kind of wrap up here with this part of the presentation, just talking about getting to those luxury specs, getting higher into the system. We showed an example earlier where we decoupled the wall with double stud wall, airspace in the middle. We can get to that 63. It's a fantastic wall from a perspective of performance, but you're using a lot of partition depth. You're using a lot of owner's real estate. We can get you to that 60, that luxury spec, if you want to use a damped panel in that system. So we have mass and damping here is the system that we're using. On the other side, we're using decoupling and mass. So those are your two pretty viable options right there to get you at 60 or above.
Thank you, Thad.
Thank you.
Oh, yep. So hopefully we've hit you with a lot. Hopefully you've got a good understanding of some terms so that we have a good conversation with our clients, and we're talking about how STCs are measured. You have a good understanding that there are different frequencies that we have to take into consideration. And of course, there's code requirements out there as well. We have a whole staff of folks that are here to help you with your particular needs and concerns on your projects that are coming up. That concludes our AIA portion. I'm going to very briefly hit some highlights. We've got resources. We are going to send an email, follow-up email to everyone with several links. And some of those, you might get a couple different follow-ups over the next week or so. And one will have links to some of our resources. But National Gypsum is the exclusive service provider for three major manufacturers, and that's Gold Bond Building Products, which is our drywall, gypsum board. Perma-Base Building Products is our perma-base cement board. Proform Finishing Products is all of our ready mix and joint compounds. And then Dexcel Roof Board is a product we can use on flat roofing as a cover board. I want to hit the resources first, and then we'll talk a little bit more about the products. We're going to send a link or take a quick picture with your cell phone of that web address there at the bottom. That's how you're going to find your local construction design manager or your local architectural rep. We are here to help you in any way we can. The three gentlemen on the right are part of our 800 National Construction Services team. Those guys are our tech folks, and they will help with everything and anything, not just sound, of course. So don't hesitate to reach out to us for any help on your projects. Most of what you saw today came from our sound book. So our sound book, if you've got one in the office, check the cover, make sure it says 2.0, the second edition of it. And what's in the sound book are very similar to what you just saw today. So you saw all of those figures, right? Figure 109, figure 120. Well, they came straight out of our sound book. So this is a great resource of all kinds of stud configurations with and without the soundboard. As you can see here, it's got the soundboard, but there's plenty in there that don't have that. We also have a resource called the Purple Book. This has been out for quite some time. This is a metal resource, so metal studs. And what we have in here, this is just an example. We've got head of wall details, how to fire stop 1, 2, 3, and 4 hour walls, deflection track fire stopping, elevator shaft stuff. On the right side, our partition doesn't line up with the beam. How do we fire stop that? All kinds of diagrams like that throughout the book with all of the UL references. So that's a great resource for your office. If you do wood construction, we've got the same exact thing except for wood. So this is called the wood book. The wood book has again, 100 plus pages of things like you see here, right? How to maintain a 1 hour rating all the way up a shaft, all the way up in multifamily, floor ceiling assembly, detailing. So lots of different things and lots of different, all the UL references, of course, are in the book itself. You can download all of those copies, and my last slide, I'll show you how to do that, or you can reach out to your construction design manager. We're happy to mail you some or drop some off to the office. Soundbreak is the board you saw that was purple throughout the presentation. It comes 5/8, so it is a Type X product, as Thad said earlier. It's we manufacture abuse resistant, meaning it will meet the abuse resistant standard, ASTM standard. So you can use it in schools. You can use it in places where you're worried about people banging into the wall, and it'll perform well. It only comes that way. We do not make a non-abuse resistant version, okay? It's mold resistant. Anything purple from National Gypsum signifies its moisture and mold resistance, okay? So the soundboard, our Soundbreak XP, is both moisture and mold resistant. So it's already comes that way. It's the only way you can get it, and it is Green Guard Gold certified. That will help with some of your sustainable design criteria. Our XP line of products, our purple line of products, is again our mold and moisture resistant. We have the standard XP, great for bathrooms, not showers, but bathrooms. That's once you step outside the shower. Basements, interior of exterior walls, moist areas, but not saunas, but kind of just damp type moist areas. It's a great option to standard drywall. We've got an abuse resistant heavy duty paper, okay, for schools and corridors and garages, things like that. And then we've got to step up from that called high impact. So the XP, as you can see, is in all these names, meaning they're purple, meaning they're all mold and moisture resistant. High impact will stop a baseball bat. It's a great product for where you're worried about people actually trying to punch or kick a hole in a wall, and you don't want to go to the expense of CMU. It's a great alternative. That being said, don't stick it between jail cells, okay? You can get through it with a hatchet, but if you don't really need the CMU, it's a great alternative. And of course, we've already talked about the Soundbreak, which is our damped panel, and then we have a shaft wall liner as well. Real quick, we've got fiberglass mat products as well. Our EXP sheathing is the purple sheathing you see all over the country, hanging on the outside of the building. We also have an internal product called EXP Interior Extreme. And you can actually pre-rock or hang drywall prior to the building being dried with our fiberglass mat product line, and we'll guarantee its use. So it kind of extends the operational time, right? So if the windows aren't in, but you need to start hanging some drywall, so MEP folks can poke holes through it, the fiberglass mat products work perfectly for that. So we've got various options there as well. Of course, we have joint compounds. The only thing I'll mention on the joint compounds, you see all different kinds of fun colors and numbers. Colors are contractor preference. The numbers are a set time. So on the left is our setting compound. It takes 20 minutes, 90 minutes, 45 minutes, 210 minutes for those compounds to set, meaning they're perfect for outdoors, okay? And they're perfect for wet basements, moist areas, because it doesn't require drying. Like the ready mix compounds on the right with the buckets and the boxes, they have to dry. So if you've got high humidity, they're just not going to dry, right? So the setting compounds are a great option for that. Again, you've got construction design managers that are happy to help you with all of this. PermaBase is our cement board that is used for its tile backer. And we also have various thicknesses and sizes. To the right, we had to do a whole AIA program on our PermaBase insulated cement board. We call it PermaBase CI for continuous insulation. As you can see, there's a simple diagram of steel studs, EXP sheathing, weather barrier, drainage mat, and then our PermaBase CI, which is cement board adhered in the manufacturing by a manufacturer to polyiso. And it comes in different thicknesses depending on what R value you need, what zone your project is in for the continuous insulation requirement. And then we can adhere thin stone, thin brick, or even a stucco, a base coat and finish coat of an EIFS manufacturer to it. Great, simple, warranted solution to meeting your continuous insulation requirements when you're going for a stone or stone, brick, or stucco type look. Protect that ISO. Big investment on our flat roofs. We have various products for roof cover boards to help protect that ISO. The reason there's different products here is because there's different applications, whether you're gluing, mechanically attaching, torching, hot mopping, asphalt, how you're putting down your flat type roof membrane. So there's different options there with our Dexel product line. We've got you covered for LEED, for Living Building Challenge, Green Globes, you name it. We've got the documentation, EPDs, HPDs, Green Guard Gold certifications, declare labels. We've got you covered when it comes to that. I introduced Jordy to you in the very beginning. She's our expert in providing all of that kind of documentation to you. Your CDM is available to help you with specifications, or you can go to our website and the various programs that are out there. And of course, our website, nationalgypsum.com, upper corner, you'll see a little search magnifying glass. Click on that and then type whatever it is you're looking for. Type sound book. It's going to pop up and you can download it right to your computer. Purple book, wood book, Soundbreak XP, whatever. You type the word in, the website works great. It'll pull you right to those products that you need. So with that, final reminder, we will follow up with any Q&A that we didn't get to. We'll also send you some links. And we apologize. I know we had some issues there in the beginning. At least I've been told we did. Apologize for that. And don't hesitate to reach out. We're happy to come to the office and do this presentation for you live. Thank you.